Hi everyone, welcome to our partner project for presentation for IT310. Our project is called GamePulse, Data-Driven Game Insights. It's designed to explore the most loved, most played, and top-rated games on Steam. Using datasets from Kaggle, we analyze how factors like genre, pricing, and community feedback influence a game's popularity. As gamers ourselves, this project is both fun and meaningful. We hope it offers valuable insights for developers and marketers interested in player behavior.
Let's walk through the architecture of our data pipeline, how we originally planned it, and how it actually turned out. First, here's the original architecture. Our goal was to start with the Steam game CSV from Kaggle, upload it to Amazon S3, then find the schema using AWS crawlers. The schema would be cataloged in the AWS Glue data catalog, making it easy to query in Amazon Athena. Finally, we had planned to use Amazon SageMaker and Jupyter Notebooks to analyze the visual and our results. However, once we started working with the AWS Academy Learner Labs, we encountered SageMaker permission restrictions. Because we couldn't pass Jupyter or create notebook instances, we had to revise our plan.
Here's our updated implemented architecture. We still uploaded the dataset to Amazon S3, we still ran a Glue crawler to catalog the schema into the Glue data catalog, and we still used Athena to run SQL queries for insight. But instead of SageMaker, we exported the results as CSV files and used Tableau Public for our visualizations. Tableau gave us full creative control to build bar charts, pie charts, line graphs, and even bubble charts, showing trends in reviews, prices, and ratings. In the end, this revised pipeline still achieved our goal, turning raw gaming data into visual insights that tell a compelling story.
No project comes without challenges, and ours was no exception. First, we had trouble uploading our dataset to Amazon S3, mainly permission errors and file formatting issues. After fixing those, we hit a bigger issue, uploading large CSV files. The Glue crawler took too long, and schema detection kept failing. As a result, many of our Athena queries broke due to missing columns and data type errors.
To stabilize things, we focused on just one smaller CSV file. The schema made crawling smoother and gave us consistent results when querying with Athena. Another big challenge was the messy structures of the data. It had missing values, inconsistent formats, and unnecessary columns that didn't align with our research goals.
At one point, we almost pivoted to a new topic entirely, but after further exploration, we found smaller datasets that still matched our original vision. We learned how to join and clean multiple files, something we'd never done before. Lastly, a big limitation was that we couldn't access Amazon SageMaker due to learner lab restrictions. No matter how we tried, we couldn't create a Jupyter notebook.
So instead of using machine learning, we pivoted to visual storytelling. We exported our clean Athena results and used Tableau Public to build interactive dashboards showing Steam game trends. Despite the setbacks, the challenges help us grow, teaching us real-world problem solving, flexibility, and teamwork. Our step-by-step tutorial on building a full data pipeline using AWS and Tableau. In this video, we'll show you how to upload Steam gaming data using AWS S3, process and structure it with AWS Glue crawler, query insights using SQL in Athena, and finally build cool visual dashboards using Tableau. For this demo video, you can pause the video anytime to follow along with each step, or check the red highlighted screenshots and the guided lab instructions we posted for extra support. Let's begin by accessing the AWS Academy Learner Lab. First, go to your AWS Academy course dashboard and clear Learner Lab. Use the temporary credentials provided to sign in. Make sure to keep that tab open in case you need to copy the credentials again later. Next, we'll upload our dataset to S3 bucket. Head to kaggle.com and search for game recommendations on Steam, which we uploaded on the link in the instructions, and download the file named games.csv. Once downloaded, open the S3 service in AWS and click Create Bucket. Make sure to uncheck Block All Public Access so that the service can read your data. Then open your bucket, click Upload, and add the game.csv file. You can pause this video here to complete your step, and once it's uploaded, we're ready for the next part. Now that our file is in S3, we'll use AWS Glue to detect its schema. Give it a name like Steam Crawler or your name or whatever you preferred, and then choose S3 as your data source and point it into your bucket. After finishing the setup, click Run Crawler. Wait a few moments and check it if your table appears under the Glue data catalog. You can also pause here for this video so you can follow along. Next, with our table ready, we can now explore the data using SQL in Amazon Athena. Select your database, choose your table, and you're good to go. Let's try some sample queries, which I will be posting here or in the guided lab instructions. First thing is the first query that gets the top 10 most reviewed games. And here we list the most expensive game price. And this one finds games available on Windows, Mac, and Linux. Once we have our results, let's download them to build dashboards. Repeat this process for every insight you want to visualize. Then open Tableau Public or desktop, and then we created several visualization, including bar charts for user reviews, pie charts for genre and popularity, and bubble charts showing price versus rating. When your dashboard is ready, export it for sharing or presentation. You can also screenshot your visual or paste them into a report. And that's it. In just a few steps, we uploaded real data, explored it with SQL, and visualized key gaming trends with Tableau.
One of our biggest takeaway was learning how to build a full data pipeline using AWS and Tableau, even without machine learning tools like SageMaker. First, we learned to start small, uploading huge files to S3, causes schema errors and long delays. Working with single CSV helps us to test faster and stay on track. We also learned that clean and consistent data is critical. Missing values and messy formatting made Athena queries fail. Missing those made our queries smooth and accurate. In Amazon Athena, SQL helped us answer real questions like, what are the most reviewed games? Which genre are most expensive? Does higher rating means higher price? Then in Tableau, we brought those answers to life. We built bar charts for top review games, line graphs for price trends, bubble charts comparing price, ratings, and reviews. Our insights here like RPG, strategy have high prices and strong reviews, but indie games, though cheaper, were still popular thanks to community buzz. In the end, we proved that even without AI tools, simply data storytelling can uncover powerful trends.
If this were a graded assignment, here's what we would submit to show our work is complete, which is in the screen.